Naming alkynes. When reading nomenclature for hydrocarbons, the two best tips I was given was to read backwards, and the carbons in the name have to equal the carbons in the structure. Here is an alkyne, and we call it an alkyne, YNE, because of this triple bond in here. There are 1, 2, 4, 6 carbons in this structure, so our name has to have 6 carbons. We're going to write our name backwards. So the first part, or excuse me, the backwards part, we're going to begin with the parent chain. The parent chain is the longest continuous chain of carbons that can be counted here. I've purposely drawn this a little crooked to kind of show how you need to really count and then double count again. The longest continuous chain of carbons, counting from left to right, is very natural and a common mistake to stick with that answer there. Counting from left to right, we get a chain of 1, 2, 3, 4 carbons. But that's not the longest continuous chain. You have to kind of snake around this right here and say, look, 1, 2, 3, 4, 5. There are 5 carbons is actually the longest chain in here. Let me count that again. 1, 2, 3, 4, 5. So always double check you have the longest continuous chain. No double backing. Continuous on a one-way street. So this is 5 carbons, is pent. And because we're talking about a triple bond that is in the carbon chain, it's pentyne. It's understood. Now, we purposely are calling this 1 to keep the counting simple. By calling this 1 and counting across the double bond, we're telling the reader that where we start is where the triple bond is. If you started here and said 1, 2, 3, 4, 5, you get a locant of a number 4. You're just making it more complicated. You want the lowest numbers possible. So count from both sides to get and determine which one gives you the lowest numbers. So this is 5 carbons accounted for. We can say 1 pentyne. It's kind of redundant because if the 1's not there, it's understood, but we're going to put the 1 pentyne in there. Now on the 3rd carbon, there is another carbon dangling off as a substituent. Now when you have 1 carbon, it's called meth. And when it's dangling off the parent chain like a pendant, we call it methyl. Now, methyl 1-pentyne, we need to tell the reader where this methyl is located. And it is a pendant that's dangling off the 3rd carbon. So this is 3-methyl 1-pentyne, or if you left out the 1, 3-methyl pentyne. We have 6 carbons in our name, 1 plus 5, and we write it backwards there. This is a model of 3-methyl 1-pentyne, and I want to note the hydrogens are not listed, are not on this model, just to kind of keep it simple here. Note that it doesn't look really like this picture right here. There are no 90-degree angles in our model here. Let me turn it like this. So it looks a little more in the orientation. The triple bond is on the right-hand side. Note that this thing turns, that these sigma bonds have free rotation. There's no rotation about this triple bond. It doesn't really flex at all. It can almost sit up like a tripod because of how this thing right here, because of how this can turn and bend right here. If you have a model kit, I recommend building these things to get an idea to build your atomic vision. Thank you.